Hello everyone, welcome to Electric Vehicles and this is Pavan Kumar. In recent days, we have seen some electric vehicles catching fire, especially in two-wheeler segment. And for that also, central government has ordered a probe for that. And after the incidents, we have seen some kind of questions from subscribers, like what kind of batteries we want to use, or whether it is possible to have other chemistries. So that kind of questions we have for this session. So now Mr. Goutham, co-founder and CTO of Race Energy, is with us to answer those doubts. Hello Goutham, how are you?
I'm good, thank you.
First of all, welcome to our channel.
Thank you.
So I just want to start this interview with a basic question. Like we are seeing n number of incidents regarding electric vehicles and batteries, right? Fire incidents, right? So may I know the reason, what is the exact reason for these battery explosions?
Right. So, if you talk about EV fires in general, we can talk about three main reasons why the batteries go into something called thermal runaway. A lot of us would have read about this term in the recent after seeing these fires.
Okay.
So, main reasons are one is the mechanical stability of the battery itself. So, if there is any physical damage to the battery, if it goes into any accident or something like that, the cells get damaged, and that could lead to a thermal runaway. That's one main reason. The other reason is how the cells are electrically used, how much charge is taken out of them, if they're overcharged, if they're over discharged, or if they are operated at operating conditions that are beyond what is specified by the manufacturer. Electrolytic or electrical abuse causes thermal runaways. And another reason could be the thermal management of the battery pack itself. As we all know, India, the summers reach up to 45-50 degrees in the north. A lot of places have very hot summers. So the batteries, if they're not designed for Indian conditions, if they're not designed and tested in representative Indian conditions at such high temperatures, and if they don't have thermal management systems to keep the cells cool, keep the battery as a whole cool during usage, during charging as well as discharging, then something called as thermal runaway happens in the batteries. Yes. So these are the three main reasons, mechanical abuse, electrical abuse, or thermal abuse can lead to electric battery fires.
So Goutham, actually we are having some questions from our beloved subscriber. So now I will ask you one by one, okay?
Sure.
So first question is from Tejas Inamdar. He is asking you that, are lithium ferrophosphate batteries a better alternative for lithium ion? And what are recent development about sodium ion battery and their ease of manufacturing? Actually, he is asking two questions.
Okay. So multiple chemistries exist in lithium ion itself. There is nickel, cobalt, manganese oxide, NCM chemistry, lithium iron phosphate, lithium titanate oxide. Each one has its own, pros and cons, if you would say. So multiple parameters like safety, performance, cost, life cycle. So each of these has its own pro of one of these parameters.
Yes.
Iron phosphate is obviously a better stable chemistry to use, but it's not we cannot conclude that it is the best chemistry of lithium ion to be used for a battery pack because it lacks performance, it lacks it's heavier than NCM or other batteries. So which cell to use in a battery pack for a particular EV usage must come from the design, from the R&D, to decide which parameters we want to optimize. Is it performance and cost and life cycles of the batteries, or is it safety and cost? So a mixture of all of these decisions is what will get you to which cell to be used. So any cell is a good cell if it's properly designed and chosen for your particular application.
So, okay, it depends on the technology what we are using, and the advanced technology may come.
Yeah, so there are a lot of new technologies coming up. Sodium ion, if you talk about it, yes. Aluminum air batteries, metal air batteries are coming up. So all of these, however, are in a very laboratory stage, I would say, experimental stage. We're still learning.
Like they are in R&D.
R&D. So it will take some time for them to be brought into manufacturing, and then there is manufacturing at scale to get to the volumes where they become economically viable to use. Right now, even lithium ion, lithium NMC or lithium iron phosphate, they have been in market for almost 10 years now.
Yes.
We are just starting to utilize them because they have become economically viable to use. The scales at which they're manufactured have made them cheaper to use it for EV applications. So even the other chemistries will come up in the future. They will take some time, to reached that stage where it's stable to use, it's cheap to use, and it's very available to use for us in India.
Right, okay. And he's also asking another question, like what are the recent developments about sodium ion battery and their ease of manufacturing in India?
Right, like I said, sodium ion is a good alternative because India does not have lithium reserves. But yeah, sodium is something that is abundantly available. Again, it's at a laboratory stage. R&D is ongoing on sodium ion batteries. It will take time before we get to the cost figures, before we get to the power density and energy density of sodium ion batteries. They apparently are very safe to use when compared to lithium ion, but it will take maybe 5 to 10 years for them to come into the market and industry to accept it as a solution.
Right, okay. And the second question is from Chandresh Jain. He's asking you that what is the scope of EV industry at present in India, considering the incidence of blasts of EV due to batteries, and what are the steps taken by the battery manufacturing and EV industries to avoid these kind of incidents?
Right. EV industry in India is itself, is at a very nascent stage. We've just started to sell a lot of EVs on road. A lot of public has accepted EV as the next step in mobility. Definitely these battery fires have put that back a little bit, set back, I would say. But a lot of industry players are coming together. The government is making it, they're introducing probes into these incidents. There are safety standards already in place. AIS 156 is one such safety standard for lithium-ion batteries, for electric vehicles batteries as such.
And also IP67 rating also is
IP67, yeah, it is another ingress protection rating. Yes. So AIS 156 is a global level standard actually. Okay. So compared to UL certification or something like that. So all the battery manufacturers have to go through AIS 156 before they can roll out their batteries into the market. Okay. So it is a standard that's coming into, it's already implemented. It's coming into effect this year from the government side. But again, this is just a standard for regulatory purposes. Okay. All the industry players should also take care of quality control from their side.
Right.
Because what I send to certify the batteries might not be replicated properly while manufacturing at scale.
Yes.
So internal checking for each and every batteries, correct selection of cells, thermal management systems and a lot of testing has to be done on the batteries, and simply importing batteries or assembling a lot of units and just putting it out is not going to work out. Right. Proper testing, proper R&D, the time that is needed for a proper new product development has to be spent because a lot of companies, in a rush to sell out more vehicles into the market, they are skipping all these testing steps and everything and going directly into the market with other third-party made batteries. So instead, if they're designed for Indian conditions, designed for Indian temperatures, the road conditions, the gradients that we have, it will be a better solution to roll out into Indian market.
Actually, in Niti Aayog draft policy also, in that also they have included this issue, right? Like most of the batteries are importing from others. They are using smart, cheap material to manufacture the battery, right?
Right. So, like I mentioned, all the three causes for thermal runaways, right? The mechanical abuse or thermal management or the electrical abuse, all of them can be controlled. There are companies, including us at Raise Energy, we have come up with solutions that can control all of these incidents. Okay. So, there's a battery management system you have to develop to control the battery's performance itself. You can cut off if the batteries go over temperature or if they're getting over discharged during usage or overcharged, over voltage protections, under voltage protection. So various band of protection systems can be implemented through the battery management system itself.
Right.
And on top of that is thermal management systems, a sturdy physical enclosure that will hold your batteries in case of any kind of accidents or drops or whatever. So there are solutions in place. It's about time the industry steps up and implements these into the batteries before they go into the market.
Right. Next question is from Deep Raj. He's asking that I have information that all the batteries fires happen on NMC batteries, and what are the safety and testing scenarios on LFP, LMO, and LTO batteries then?
I'm not sure if all the incidents are related to NMC. Like I said, each cell chemistry is good for particular applications. You cannot say NMC is good for this or LiFP PO4 is good for this. It all depends on how the powertrain of the vehicle is designed and what is the current demand from the powertrain and what your expectations are in terms of life cycle and performance parameters. So accordingly, the cells will have to be selected. On the testing side, like I mentioned, AIS 156 is the global level standard that India already has. It includes multiple levels of testing, including mechanical tests, vibration tests, fire tests, in fact, and also water resistance, external short circuit tests, a range of tests that put the battery through very extreme conditions. That is already included in AIS 156, and that is like the passing standard for any kind of cell, be it lithium iron phosphate or NMC or whatever other chemistries that come in the future.
Right, okay. And one of our subscriber, Mr. Dinesh, is asking that most of the batteries are packed in a closed container without a heat sink, excluding Aether and Ola, and ask him what is his take on this. Like, what's your point of view on this?
Like I said, thermal management is the basic funda to reduce the chances of battery fires. Each cell heats up when it's charged or when it is discharged. So there has to be some mechanism to extract this heat and keep the cells cool. By cool, I mean within the operating range specified by the manufacturer. Most manufacturers specify between 25 to 40 degrees within which the cell has to be used or the battery itself has to be used. So any kind of thermal management, it might include a heat sink outside or it might not. It might include a liquid cooling system without any heat sink, without a external heat sink as such. So that has to be implemented in the batteries. A lot of companies are doing that as we speak. A lot of R&D has been put into this for thermal management of the batteries as such. Okay,
actually we are having BMS, right? So their function is this only, right?
So BMS cannot control the temperature of the battery. It will only sense, okay, the battery is at so-and-so temperature.
Just
monitors and cuts it off. So I can mention to my BMS, if I have designed it and if I have the control, I can tell the BMS to cut off functioning of the batteries if it goes beyond 40 or 45 degrees. That means when we are charging or when we are discharging, as soon as the temperature point reaches 45 degrees, if it is sensed by the temperature sensors, the BMS will shut it down. That means the battery will not operate beyond that. So that's the function of the BMS. Same with overcurrent or over discharge, whatever. But how to stop the batteries from reaching that temperatures, you'll need a dedicated thermal management system. You need to extract the heat from the cells to keep them cool, to keep them operating at the safe operating range.
Right, okay. And the next question is from Aditya RG. Only one question: is there anything that can replace current battery technology and will be much more effective than lithium ion? Also, is there any tech that we can use the vehicle over solar in a daytime, especially in summer, without adding additional parts?
Okay. Different chemistries will definitely come up. Different kinds of battery technology is already in the R&D phase as we speak. Historically, we've used lead acid batteries in the past. Then we transitioned to lithium ion batteries. I would say we are at a nascent stage in lithium ion batteries itself because the cathode and anode materials of lithium ion batteries are constantly evolving. It almost at a rate at which every month there is something new coming up in discussions, in theory at least. But for these to materialize, to come into the market at scale for commercial usage will definitely take some more time. And this is just lithium ion. There is sodium ion, there's metal air batteries. So all of these will definitely come into the market. It will take time, maybe 5 years, 10 years. And industry, how it's going to adopt it. Are there going to be battery manufacturers setting up the plants in India? That will also determine if it's going to be easily available for us. And if we are going to be dependent on other countries, that's a question that we have to see.
Like there are a lot of factors that can cause that kind of advanced lithium ion battery technology, right? Okay. And next, Mr. Ashok Kumar Kristam is asking, what is the best battery for EV and what is the cost, durability, safety, charging time and performance of it?
Right. There is no best battery for EV. Like I mentioned, each EV has its own powertrain, motor power, controller requirements. So every the battery has to be custom designed for each EV. Again, the voltage levels will differ. A car might operate at 400 volts, but a scooty or a three-wheeler might operate at 48 volts or 60 volts. So there's no one battery that fits all the segments right now. If you talk about charging times and if you talk about battery management as such, there are again different options available. There's battery swapping that is coming into the
Yes.
picture, where the user does not have to worry about the battery at all. He just uses it as a fuel, just like refueling at a petrol station.
Yes.
They just go to the battery swap station and exchange the batteries. So that is one option where the headache of the batteries is taken away from the customer in terms of cost as well as battery management.
Yes.
Everything is taken care by the battery operators, battery service providers, and the user just uses the vehicle just like he would on a IC engine vehicle.
Okay, right. And the next question is from Mr. Sachin Tamrakar. How to maintain our lithium-ion battery in our existing vehicles for maximum output and long life?
Right. So for maximum output, obviously you should not over discharge the batteries. There are companies that offer boost mode or hyper mode or all these things. That is good for acceleration at specific points of time, but you should not continuously overuse that. That basically means you're drawing more current from the batteries at all times. So the slower you charge or slower you discharge a battery, it's going to last longer for you. And as soon as you come back home from a long ride in a EV, you should not directly plug it into charging, because the batteries are already warm.
Yes.
And in a fixed battery system, there is no cooling as such involved. So you need to let the batteries rest for some time and then go for charging. That will help prolong the life a little. Again, once you've finished charging, it's not suggested to go directly out for a long drive, because again, charging has just completed, the cells will be hot. Again, if you take it out, you're going to destroy the batteries inside. All these are with fixed battery systems. With swappable batteries, however, you do not have any of these problems related to that, because you go and swap the battery. You do not have to worry about the battery life cycle or the battery management or the charging the batteries, charging time as such. You can just drive around as much as you like. Again, comes with its pros and cons in itself.
And the next question is from Mr. Kishore. His question is, when will aluminum air battery will launch in the market for electric vehicles?
So aluminum air is one promising chemistry of batteries that is, the government is also supporting that. There are companies in Israel and other countries who have partnered with Indian companies to take this forward.
Okay.
Again, these are at a very initial stage of development. R&D is happening. Again, 5 to 10 years is a rough estimate of when we can see these being used in the market, because the related infrastructure for aluminum air batteries and their recycling, their charging, that also needs to be developed before we get these into the market as such. So 5 to 10 years maybe before we start seeing these in vehicles that are coming up.
Right. Okay. And Harish Chaudhary is asking that does fast charging ruins the battery life? And how to keep cool the battery? Does temperature affect the performance of battery?
Right. First, answering the temperature part. Temperature affects battery life. Okay. The more you use batteries at higher temperatures, the more you are destroying the battery's internal components. Okay. So, like I mentioned, you need to operate the battery and its cells within the safe operating range, within the temperature range that is recommended and tested by the manufacturer. So the cooler you can operate your batteries within that range, maybe 25 to 30, 40 degrees in Indian conditions as well, even in summers or winters, that is going to prolong your battery life. And the other question?
It's about fast charging ruins the battery life.
Right. So fast charging depends on what kind of fast charging you use. There are different modes. There is pulse charging that is available in the market. There is direct fast charging that is available. So if the battery is designed to hold fast charging, it will operate well and good. But if the battery is, again, just put out in the market just for the sake of fast charging, if you're fast charging it, that will definitely ruin the batteries. So for example, we at Race Energy, we do not fast charge the batteries. Okay. We follow a very standard protocol for charging the batteries. We vary the currents in such a way, we charge the batteries as slow as possible to prolong the life of the batteries. So that is how it works.
Right. And another question is how to keep cool the batteries?
For fixed battery systems, again, after a long drive or after charging, you need to rest the batteries before you take it out for usage again. Maybe park the vehicles in shade in summers, that will help a lot. Do not overuse any kind of hyper mode or boost mode or extra discharge modes,
Yes.
fast modes in the battery.
Yes.
That is good for acceleration at times. For complete usage, I don't think that is a good way to go ahead. So whatever eco modes or normal modes that you have in your vehicles, that should be your normal mode of operation,
Yes.
and that will make sure the batteries are not over discharged or they don't heat up quickly.
Right, okay. And the next question is from Yashwant Pujari. He's asking you that what are alternatives for lithium, as there seem to be shortage of lithium and hence prices of battery packs are very high.
There are new reserves of lithium being explored every day as we speak. So,
Okay.
obviously, lithium reserves are specific to a few countries right now. That is why new chemistries like metal air batteries, aluminum air batteries, or sodium ion batteries, sodium being abundant in India itself. So these are coming up day to day. Discussions are happening. R&D is happening in these sectors. But I think lithium ion will still persist for a long time to come before any of these other chemistries start rolling out into the market.
Okay. Mr. Sikat, one more. Mr. Sadasivam is asking that how this EV industry will progress in coming days, considering this lot of thermal incidents we are seeing.
Right. So it is a setback, I would say, because the customers are now worried about, do I have to go, which kind of batteries to buy. The end users who were accepting EVs as the next form of mobility are now questioning, do we have to wait a little more, or are there already solutions in place? My answer is yes, there are solutions in place. Already there are industry players, including ourselves, who have implemented the solutions into our battery design and testing. It is only a matter of time before all the industry stakeholders adopt this, spend more time into testing before rolling out the products into the market. That will increase more confidence in the end user to buy these batteries.
EVs.
And like I mentioned, AIS 156 is standard that will communicate to the end user that the battery has undergone a lot of rigorous testing, certified by the government, and that will give more confidence in buying vehicles from here on.
Right, okay. And the next question is from Prashant. So he's asking 2-3 questions. I'll tell you first thing. What battery based material can give you a sustainable future in EV industry? And looks like Toyota has been succeeded in new sodium battery. Could that give stable solution to the EV industry?
Yes, sodium based batteries are again on a lot of talks because they are the raw materials are easily available, abundantly available, and they seem to be a stable form of chemistry to use in electric vehicle applications. But again, the question of manufacturing these batteries at scale, bringing the volumes to that scale where it will be economically viable for the EV community, that is going to take time. Definitely, it will be a good solution going down the future. How much time it takes to get this out to the market and get the certifications to roll these out into the market is something we have to see.
Yes, okay. And he's also asking one more question. How better is the battery swapping method? Can regenerative battery be successful? And if yes, how? Do battery startups have to wait for stable battery technology?
So battery swapping is it has a lot of advantages over fixed battery systems as such, because the cost of the batteries and the management side of the batteries is removed from the vehicle, and that means the customer or the end user does not have to worry about charging the batteries or keeping the batteries cool, or replacing the batteries after a few years when the end of life usage comes. So all of the battery related concerns is taken right out of the vehicle and the end user, and the vehicle becomes cheaper to buy for the end user as well, because the battery itself constitutes around 50% of the vehicle cost. So it becomes half as cheap to buy an electric vehicle for the end user. And on top of that, it makes more sense for battery swapping if the end user has to be on road for a long time, like commercial users, fleet users, because within a matter of 2-3 minutes, you can swap the batteries at any available battery swap stations, and you can be back on the road instead of having to wait for 3 hours or 5 hours for charging the batteries if you have a fixed battery system.
Yes.
So that's like the main advantage of battery swapping as such. And there are recent battery swap policy has also been
Yes, Niti Aayog
come
draft
out from Niti Aayog. So that is a good boost towards battery swapping, and a lot of incentives and policy related incentives have come up in the draft, and we as automotive industry stakeholders have given our inputs to Niti Aayog to make the policy better and drive it towards implementation.
Do battery startups have to wait for stable battery technology now?
No, I think the battery technology is something the industry has to develop. The stable cells or stable chemistries have already been established. It's only about how the battery is designed around these cells, how the thermal management, how the electrical management is designed and tested for each vehicle use case by the industry. No one has to wait for any technology to come up. It's already there, existing since the last few years. A lot of companies have already implemented this in their systems. So it's all about designing, it's about understanding the physics of the battery, understanding how your vehicle will use the battery, and designing it and testing it according to that.
Okay, actually I'm also having a question for you. Niti Aayog has already given a draft policy regarding battery swapping technology, right? Is it a boon or bane to you?
I would say it's a boon because recognizing battery swapping itself as a mode to push electric vehicles into the market is a good recognition for all the players that are going into battery swapping, including us. So it is a definite boon, and on top of it, with all the policy related incentives that are coming up for batteries, subsidies that are going to be given out as part of the policy, that will definitely give more incentive for battery manufacturers and battery service providers to establish themselves into the market and grow as ecosystem together.
Right, okay. And next our subscriber is asking, his name is Pavan Kumar. He's asking you that Pulsar NS 200, RS 200 kind of bikes uses liquid cooling system on IC engine. Then why EV or battery companies are not using the same system on EVs motors as well as batteries?
So there are EV motors that in the market with liquid cooling systems. If the vehicle requires that kind of cooling, definitely there are solutions available, but they are a little expensive to use. So that could be one reason. On the battery side, however, liquid cooling is not the only solution. You can use different kinds of conduction-based cooling or radiative cooling. You can have a heat sink around. So there are multiple different ways in which you can cool a battery pack. There are companies like Tesla who use liquid cooling in their batteries. There are companies who do not use any kind of convective cooling. They use something called conductive cooling. They have plates of aluminum or something on the base that extract the heat out. So each battery design is dependent on the vehicle use case, dependent on how the battery is going to perform, also dependent on what kind of cells are inside that constitute the battery module. So depending on that, what kind of thermal management to implement is to be decided. And
the last question from our subscribers, his name is Super Investor. He's asking that can we go for lead acid battery over lithium batteries safety wise and price wise?
I would say lead acid batteries are a thing of a past, because we have moved on from lead acid batteries to lithium ion. Going back to them will only be taking a step backwards.
Okay.
Definitely lithium ion is improving day by day. The different chemistries that are coming up, the different safety factors that are coming up into each cell manufactured will make it better for the users to use it, because they have higher power density, they operate much better, increased performance levels compared to lead acid batteries. So lithium ion is the way to go forward for the next few years before new chemistries come up. Going back to lead acid is like taking a step back. So that's how it is.
Right, okay. Actually, I'm also having a doubt. We are having charging stations on one side, and on other side we are having battery swapping stations, right?
Right.
So are they competitors to each other?
No, they're not competitors. They will coexist going into the future. Which segment of the vehicles adopt which kind of batteries charging is something we have to see.
Right.
Battery swapping makes more sense for commercial and fleet users and a few personal vehicle users as well who do not want to wait for charging or who want to adopt EVs at a much cheaper rate. Battery swapping can be done in a matter of 2 to 3 minutes. So these guys do not have to wait for charging, and they can spend more time on road rather than waiting for charging. Battery charging model as such will make sense again for passenger vehicles who travel not more than 50-60 kilometers a day, two-wheeler users, and four-wheelers who drive within the city, who can charge at their residence, or who have public charging infrastructure available to use. So definitely there's going to be coexistence of both the systems, battery charging as well as battery swapping, and different segments of vehicles will use both the things hand in hand. So that's how it's going to evolve, in my opinion.
So that means there will be no problem to the charging station owners also?
No, definitely not, because in the same place you can have battery charging infrastructure as well as battery swapping infrastructure if the power demand is met. So it's not going to be a competition at all. Both of them are going to serve the EV mobility space as a whole. So both will coexist.
So, and one more question for you is that how far this battery swapping technology is safe? Like if anything happens in battery swapping, like while we are swapping, anything damages, it could be a great it could be a great minus point to the battery swapping, right?
Right. I would say battery swapping is much more safer because if I talk about Trace Energy's battery swap stations, we maintain the batteries at air conditioned temperatures.
Okay.
Our chambers that hold the batteries in the battery swap station, they cool down the batteries as soon as they come in from the vehicles before they even start charging. Okay. So because the battery is in our control or any battery service provider's control, we can maintain the batteries at low temperatures before charging them, as well as cool it down after charging them before giving it out to the user, which is not possible in the case of fixed battery systems. They cannot cool the batteries externally before charging it or something. So battery swapping is a much safer option, I would say. It prolongs the life of the battery as well, because it's maintained in proper operating conditions while charging. And whenever the battery comes into a swap station, all the data regarding the battery's performance, the internals of the batteries, state of health of the batteries, we get all of that from our batteries into the system. So we can predict if anything is going wrong with the batteries. We can analyze what's wrong with any particular battery and take it out of the system, service it and put it back, which is not possible in case of a fixed battery system. So in these ways, battery swapping gives a better life to the batteries, I would say, when compared to fixed batteries.
So thank you, Mr. Goutham. Thank you very much for your time and valuable information.
Yeah, thank you so much.
So that's all for now, guys. I think we have covered all the doubts that you are having in this session. And if you are also having any questions and doubts regarding electric vehicles, we would like to announce that we are going to start Ask Electric Vehicles 2.0. So if you are having any doubts, please let us know in the comment section, and we will answer the questions in the next video. And that's all for now. If you like this video, give it a big thumbs up, and also share this video to your friends and family members. For more such videos, please subscribe to our channel and press the bell icon to get instant notifications whenever we upload the video. So go green, go electric.